All right, Wildcats, we got some exciting news. Today, we're doing the unit circle. Unit circle, unit circle. Today is unit circle day. An exciting day. Super exciting day. Okay? It's unit circle day. All right, so unit circle day is on Wednesday, May 10th, and then notes are going to be on 82. So if you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the unit circle, the one, the only. So special, the unit circle. Okay, so this unit circle page is going to go in your notes. Okay, so when we start with the unit circle, okay, we're going to start with quadrant 1. Okay, all right, so the way to look at this is to look at this angle. Okay, now at this point I'm drawing a yellow line. If you want to have the same colors as me, I'm going to use yellow, green, and pink. You don't have to, but I really recommend using colors. So I'm actually going to let you pause for a minute. I'm going to go run and get some more colors. You should go run and get some more colors, and then we'll meet back in 28 seconds. All right, 28 seconds later. All right, so now to look at this angle, okay, I want you to see that this piece, okay, if we count pieces, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them, okay? Now, if we're talking about a circle, that's out of 360 degrees, okay? Going from 0 to 360, okay? So if that's 360 degrees, then that yellow piece, okay, is 360 degrees divided by 12, which equals 30 degrees, okay? So we know that that piece is 30 degrees. Okay. Now the next piece, I'm going to use green here. You don't have to use green, but you really should do this one color. Okay. This piece, okay, is if we count, that's 1, 2, 3, 4. So there's 4 in the first half, there's 4 in the other, so it's a total of 8. So that piece is broken up into 360 degrees divided by 8. So that's 45 degrees. Okay. Now this next piece, using Wildcat pink, okay. Well, if we look at how many pieces there are of this, so that's 1, 2, 3. So there's 3 in the top half, 3 in it, so it's a total of 6. So that's 360 degrees divided by 6, which equals 60 degrees. Okay. All right. So now I'm hoping we remember the bow tie, because the bow tie, if we take this yellow and we apply the bow tie, then we'd have this piece, and this piece. Okay, so we use the bow tie for reference angles. We know reference angle is here 30, so we know that from here to here is 180 degrees. Okay, So referencing, we know to get to here, we take 180 minus 30, because that's our reference angle, which is 150 degrees. Okay? Now, from here, our reference angle is 30, but we're going this way, so here 180 plus 30 is 210 degrees. Okay? Now, here, we're going reference, we always reference the x-axis, so 360 minus 30, which is 330 degrees. Okay? Now, I got ahead of myself a little bit because I'm so excited. I mean, this is unit circle day, okay? This is the best day in the entire mathematical world, unit circle day, okay? What I'm going over is a foundation of pre-calculus, okay, is a unit circle. You're going to use this on a lot of concepts. So what I'm teaching you and the way I'm teaching you is that you could recreate this unit circle from scratch. And that's important because in advanced academics, you're going to have to memorize this unit circle. And so, and a way to memorize is to teach you how to recreate it and create it, okay? So I'm teaching you this way that you can fill in all this information from memory and concepts, okay? All right, so now we're going to bow tie 45. Okay, so that is here. Okay, here. You notice it's making a bow tie, okay? Okay. So in this case, our reference angle is 45 degrees. So referencing here, we go from 180, we're subtracting 45 degrees, so that is 135 degrees, okay? Now here we're adding 45 degrees, so that's 225 degrees, okay? And then here, referencing 360 minus 45, which is 315 degrees, okay? Now let's look at 60. So let's make our 60-degree bow tie. Okay, so again, reference angle is 60 degrees. So here, remember, we reference the x-axis, so 180 minus 60, which makes this angle 120 degrees. Here, we add 60 to 180, so that's 240 degrees. And here we take 360 minus 60, that's 300 degrees. Okay, so that's how you get all the degrees around the unit circle, okay? Now the next step would be to do it based on pi, okay? So, and using the first quadrant as our reference, okay? Now, we know that this is 0, okay? And we know a full circle is 2 pi, okay? So, we know that this is still 12 pieces, so this would be 2 pi divided by 12, which reduces to be pi divided by 6. So this is pi divided by 6, okay? Now the next one is, we know it's 2 pi based on 8 pieces, which is pi divided by 4. Okay, and then this we know is out of 6 pieces, so that's 2 pi divided by 6, which is pi divided by 3. Now I recommend taping, as you can see, this separate sheet of paper to this as a reference of where we based our initial quadrant. Okay, once you have this first quadrant, you can basically complete the whole circle. Okay, so I'm going to put this off the side, but at the end of the video, I'm actually going to tape it probably right here so I can reference that when it comes to the first quadrant. Okay, all right, now going around the circle, again, thinking of the reference angle, here our reference is, we go from 0, we know from here, this is half, well, half of 2 pi is pi, and then half of pi is pi divided by 2. And I almost forgot that this is 90 degrees. Okay. Now, referencing here, well, this is pi divided by 6. So this is pi minus pi divided by 6, which is 5 pi divided by 6. And then here, reference angle is pi divided by 4. So pi minus pi over 4 is 3 pi divided by 4. Then here, our reference is pi divided by 3. So it's pi minus pi divided by 3, which is, let's see, 2 pi divided by 3. Okay, so now, again, going around the circle, our reference here is pi divided by 6. So this is actually pi plus pi divided by 6, which is, let's see, 7 pi divided by 6. And then here, again, our reference is pi divided by 4. So we take pi plus pi divided by 4, which is 5 pi divided by 4. And then here, this is pi divided by 3. So pi plus pi divided by 3 is 4 pi divided by 3. Okay. And I almost forgot that this is 270 degrees. Okay. And then going here, well, this is 1/3 of 2 pi. So this is 2 pi. No, hold on. Let me think about this. Ask me about this one in class. Okay. And we can figure out the pi there. Okay. So, but then going back to our reference, here our reference is 2 pi. Okay. So we take 2 pi minus pi divided by 3. And you know what? Let's go ahead and work these pi values in class, okay? Let's go ahead and work these pi values in class, okay? All right, so we'll finish that part of pi in class. Now let's move on to the points, okay? Now, the points, you'll notice, okay, are an x and y value, okay? Well, we can find those x and y values by making a right triangle, where this is the radius, this is the angle, this is x, this is y, okay? Now, in a unit circle, the radius is equal to 1. It's always equal to 1. So from here to here is 1 all the way around, okay? So that means this length is 1, this length is 1, this length is 1, okay? So we're going to use the right triangle. So, well, we know that this is a 30 degrees, okay? So this triangle right here is a 30, 60, 90 triangle. So to find x and y, we're going to use the principle or the concepts from 30, 60, 90, okay? So I'm going to take this yellow triangle and I'm going to bring it down here. And if you want to pause for a moment and, well, not pause, let me walk you through it, okay? And then you can write down as we go. So we know we're looking at a 30, 60, 90 degree triangle, okay? Well, going back to our table, we know 30, 60, 90 is x, x squared, 3, and 2x. Well, we know that this radius is 1, so that we know that 2x equals 1. Well, if we solve for x, x is 1/2. So x is 1/2, and this is square root of 3 divided by 2. Well, we know that 30 is across from x, so this is 1/2. And we know that square root of 3, 2 is across from 60. Okay? So now we have our values. Okay? Now we can use trig here because we know that sine of theta is opposite, which is the y value, over the hypotenuse, which is the radius. Okay? Now we know that cosine of theta is adjacent, which is the x, over the radius. Okay? And we could talk about tangent, but I don't think we need tangent at this time. But remind me in class and I'll talk about tangent. Okay? All right, so now we know that sine is y over radius, which radius is 1. So really sine is the y value and cosine is the x value. Okay, so in this case, the x value is square root of 3 over 2, and the y value is 1/2. Okay, so this point is square root of 3 divided by 2, and this is 1/2. Okay, all right. So here, okay, is we're going to take this triangle, which is a 45 degree 90 triangle, okay, and apply our concept. So we know we have our table, which is 45, 45, 90, and we know that it's x squared root of 2, okay? Well, we know that 90 is 1, so that means x squared root of 2 is equal to 1. So set x squared root of 2 equal to 1, divide both sides by square root of 2, you have x, but you have to multiply to get rid of it. You can't have square root in the denominator. Square root of 2 divided by square root of 2 equals square root of 2 over 2. Okay? So that means x is square root of 2 and x is square root of 2. So this is square root of 2 divided by 2, and this is square root of 2 divided by 2. Okay? Now we know that sine is the y value and cosine is the x. But in this case, the x and y are the same. So this point is the square root of 2 over 2, and this is square root of 2 over 2. Okay? Now, we don't need to draw another triangle because this is a 60-degree triangle, okay? So we know that 60 is going to be here, okay? So this is going to be reversed, so it's actually going to be the x value is going to be 1/2 and the y value will be square root of 3 over 2, okay? So this point is 1/2 square root of 3 divided by 2, okay? Now, the cool and so exciting part of the unit circle is once you have this quadrant, you have every quadrant, okay, with this simple concept. We know that every point in this concept is positive and positive, okay? We know that every point in this quadrant is negative, positive, okay? So here's the thing, okay? Now let's go around. I almost forgot. This radius is 1. So in this case, this is 1, 0, okay, because the y value is 0 because you're on the line. Now going around, the x value is 0 here, and the y value is 1, okay? Now, if we go around, this is a negative 1, 0. Well, see the reference? These are the same values except for the x values are negative. So all you have to do is once you know this point, you know that these are plus plus, but this point is negative positive. So this is negative square root of 3 over 2, 1/2. Okay, because the y value is positive. And it goes same thing here. All you have to do is know that the x value for this point is now positive or negative. So negative square root of 2 square root of 2 over 2. Okay, same thing here. Negative 1/2 square root of 3 divided by 2. Okay, now going around. Okay, well, the points in this quadrant are negative, negative. So, but all basically these are the same points. Now follow the yellow line, okay, because that's your reference. Follow the green line, follow the pink line. Same point except for both negative. So negative square root of 3 over 2, negative 1/2, negative square root of 2 over 2, negative square root of 2 divided by 2, and negative 1/2 and negative square root of 3 over 2. Okay? And then here, again, same points, but this quadrant is positive, negative. So following, connecting the yellow line, so this is positive square root of 3 over 2, negative 1/2. This is a positive square root of 2 divided by 2, negative square root of 2 over 2. And this is 1/2, negative square root of 3 over 2. Okay? And with that bigger picture, wow, the unit circle is so grand, it doesn't even fit in a whole picture. Oh, wait, almost did. Yep. Okay. So, oh, almost forgot. Point here is this would be 0, negative 1. Okay, now I went over the whole unit circle in this video because I wanted you to see it because it's so amazingly intense. It's like you were probably like, whoa, after you saw it. That's like, oh, what in the Wildcat, Mr. Luke? This is crazy Wildcatness. Okay, but don't worry, I'm gonna actually in class go over this all over again because it's so awesome. It's so fun to do. I think honestly, this is probably the coolest thing you can do. In fact, you should probably get another one of your papers and just do it all over again a couple of times. It's so fun. Okay, but we're gonna do it all again in class, and then I'll go through, and then you can ask questions, and we can talk more about it, so that you can again do this on your own. Because again, this is a required. You have to be able to recreate all of this from scratch. Okay, in pre-cal. Okay, so with that, have a unit circle Wildcat day.